In this video, we'll talk about independent samples t-test using SPSS. Independent samples t-test is used to test if there exists a difference between the means of two distinct groups. Before talking about using SPSS, let's just take a look as to how data is written in Microsoft Excel if we are to do the same, that is t-test for independent samples. So our samples are basically listed in two different columns. So that is for Excel. In SPSS, the way that this data will be encoded will be a bit different. So let's go now to our data, same data as encoded in SPSS. If you will look at the data, so our work area here is still composed of two variables, but this time the variables are presented as group and score. So I'll have here my first 50 scores under group 1, and since group 1 is arbitrarily assigned to male, so this will be the scores for the male, and then I assigned 2 to represent female, and I have here my next 50 scores for the female. So that's basically how you write or you encode data in SPSS as you compare the means of these two groups. You could actually go to the variable view and then type the name here for the group and then scores. Another thing, if you'd like to assign values to your group, this is by default clear, so I'll clear this. So that's just 1 and 2, but I have my representation for 1 and 2. To do that, I may click on group here, click on values, click on the dot here. I'll type 1 and type in male here, and click on add 2, and then female here, and then click on add. So this is basically used if you'd like to have a better presentation of your data, if you'd like male to be presented first before female. And then let's click on OK now, and let's run the independent samples t-test. To run independent samples t-test in SPSS, all you have to do is to click on Analyze. You go to Compare Means and then choose Independent Samples t-test. So as you can see, you have two parts here for the right panel, the grouping variable and the test variable. So for the grouping variable, I'll click on group here and click on the arrow to the right here. So, and I may now define the groups. Since I assigned 1 for the male, so I'll click define groups. So my male will be group 1 and female will be for group 2. And then for the scores, I'll click on scores here and then put it under the test variable. And under options here, my confidence interval percentage is set at 95% confidence level, so we do not have to change any of this. All you have to do is to set grouping variable and test variable and then click on OK. So this will be the descriptive statistics showing the mean and standard deviation of my two groups. And as you can see here, I'll double click on this part. As you can see here, I have here the equal variances assumed and equal variances not assumed. And I have two t-values, although they are the same, and the sig value. So what's the purpose now of these two values? What value will I be getting assuming that they are not the same. First things first, remember that we have the test of normality as one of the assumptions for most parametric tests, and particularly for independent samples t-test. Another added assumption is the test of homogeneity of variances or equality of variances. So that is once again another assumption. If again, so you refer at the Levin's test of equality of variances, if the sig value here is greater than 0.05, then you will be fetching the values under this row, the first row. Again, if the sig value is greater than 0.05, you'll be getting the t here and the sig here. However, if the sig value is less than 0.05, you will be getting the value under the second row, that is equal variances not assumed. So you'll get the t here and the sig here. So I hope that's clear. Again, so if the sig value is greater than 0.05, you get the t on top and the sig on top. If the sig value or the p value is less than 0.05, you get the t value at the bottom and the sig value at the bottom. In this particular case, there's not much difference, but if you look at the tooltip text popping, so the sig here is 3.10 e raised to negative 18. The sig here is 9.68. So there's a bit difference. For this one, almost the same. So I'll just be copying this. Since the sig is less than 0.014, so I'll copy the bottom value here, the value at the bottom, and then copy and then paste this under my table. And then for the p value, since it's 0, so I'll just type here less than 0.01. My interpretation is significant. Again, my decision is to reject the null hypothesis. Again, if the p value is less than 0.05, interpretation is significant, you reject the null hypothesis. If my null hypothesis states that there's no significant difference in the scores of male and female students, rejecting it would mean that there is a significant difference in the scores of male and female students. If the p value is greater than 0.05, then the interpretation becomes not significant, and the decision is now accept HO or null hypothesis. So that's it. So that's how you use SPSS in determining the needed values for the independent samples t-test.